Okay, we'll start Friday's Zoom meeting, Math 1113, trigonometry. We will start off with some problems. Section 4.5. It's page 404. And why don't we start with one like 13? Tough to remember what I worked last time. Hopefully these are new ones. Might help you out if you happen to view this. All right, so this is intended to be an easy one. Equation to solve. We want to solve this. And showing an E, we want to take the ln. ln of e to the negative 5x is then equal to ln of 10. These undo each other, leaving the negative 5x, ln of 10. Last move is to divide by the negative 5. Leaving x is then ln of 10, divide by negative 5. And we can punch that and get a decimal. Ln of 10 divided by a negative 5. Negative 0.4605. So yes, with exponentials, you want to take ln, and the only L log you need is ln. Working further down the page, how about something with a really odd base like number 19? Maybe I'll start on a fresh sheet so I don't have to switch in the middle in case it gets long. 19. Still off page 404. Solve 300, 1.025 raised to the 12t equals 1,000. You got some weird numbers in this one, weird bases. I don't know if this makes you scream, why did I sign up for this class? But I would first divide by the 300. It doesn't go evenly, so rather than write out decimals, I'm going to leave it 1.025 to the 12t. I'm going to reduce it. You can cancel out 2 zeros, 10/3. I'm going to reduce it to 10, but you can leave it 1,000 over 300. Now, this kind of illustrates you don't really want to mess with a log base 1.025, but you could on both sides. I just use ln 1.025 raised to the 12t, ln of 10/3. But ln base e will not cancel this directly, so this is a signal to put the 12t to the front is equal to ln of 10/3. These are equivalent by the third law, so there's not a case of doing you did something to one side but not to the other. You're just using the third law. You can replace this with this, and now you just want to divide by 12 and the log of 1.025. This is a case of you got to do it to both sides. Now cancel the 12s, cancel this, and t is then equal to, this is called the exact answer, 10/3 divided by 12 and log of 1.025. That's what you would get by the change of base. If you had used the log of 1.025 up here, you'd have got a log of 10/3, or right here, log base 1.025, you got that would have directly canceled, and then you got a log ln of 1.025 over here. All right, now this is not the easiest punch, but I'll write it out horizontally. ln of the 10/3 divide by, now you're going to need a parentheses, 12 ln of 1.025. I'll have parentheses there on the calculator, another set there. Punch it all at once. And divide by 3. Divide by parentheses 12 ln 1.025. Close and close. It'll tell you give an error if the parentheses aren't matched, but I'm thinking and hoping that that will actually work. I'm getting 2.4203. 2.42. There we are. 4203. All right. Why don't we try another one here? Something with more algebra. Might be something like 35. 2 to the 3x plus 1 equals 3 to the x minus 2. Once again, you don't really want to mess with log base 2 here. You do it to this side. It doesn't match this, it doesn't cancel this side with the, or log base 3. Just use ln on both sides. ln of 2 to the 3x plus 1, ln of 3 to the x minus 2, and that doesn't cancel either side. But it does allow you to stick those exponents in the front. Stick them in parentheses because they've got multiple pieces. ln of 3. Now, I could go ahead and punch in the decimals for these, but then you get nasty decimals on both sides. There's several ways to play it. To keep the nasty decimal on one side, I'm going to go ahead and just divide by the ln of 2. That'll cancel this, 3x plus 1. X minus 2, and now I will punch and get the one nasty decimal here. Yeah, okay. ln of 3 divided by ln of 2. 1.585, we'll call it. So then 3x plus 1 are in like terms. I'm going to get 1.585x here minus, I'm distributing through from the back side. 1.585 times 2. $3.17. Now it's a matter of just moving the x's to the left, numbers to the right. So minus 1.585x minus 1.585x. And you never punch the x. You can just go 3. 1.585, 1.415x equals negative 3.17. Subtract 1, subtract 1. 415x is then negative 4.17. Final move, divide by 1.415, divide by 1.415. And you'll get the decimal. It probably might be off on the back of the book a little bit, but it would be close enough. Oops, got a zero. Okay, negative 4.17 divided by 1.415. Negative 2.947, we'll call it. If you wanted to check this to give yourself any confidence, you could go 2 to the 3 times negative 2.947, add 1. Should come up pretty close to 3 to the negative 2.947, subtract 2. Let's see how close I get to both sides with all the rounding going on. So I'd raise 2 raised, and in parentheses, you can see if I just laid it on the ground. 3 times negative 2.947, and add 1. 0.00436. On the other side, 3 raised. I know you can't see this, but I'll punch it here. I'll show it up so you can here. Negative 2.947, subtract 2. Enter. Well, starts to first 6 digits. Checks to the first 6 digits. 436. If that gives you any kind of confidence in it. Of course, you don't have to do this, the check, you use the back of the book, but that's, even though we did some rounding in the middle, it's still fairly accurate. All right, let's see. Jumping over to some log equations. I believe we did 49 to 53. I think we did 49 to 51 last time. Let me try number 50. Solve. This is still off page 404. Log base 5 of x plus log base 5 of x plus 1 equals log base 5 of 20. Once again, you can combine the left side. Making log base 5 of x times x plus 1. Log base 5 of 20. And log equations are different. You can't, there's not one single thing you can use like exponentials. Like on exponentials, you can use ln. But here you really do have to read the base and use whatever base it is. Use, in this case, base 5. Log base 5 of x plus 1. 5 to the log base 5 of 20. We'll undo. X times x plus 1 is then equal on the other side to 20. Distribute left side. Bring the 20 over. Equals 0. Notice the quadratic pattern that'll factor and give us whole numbers. Again, very common, one will work, one will not. You got to make sure you can check them up here and get positive logs. But I think we did one last time that both worked. But we'll see how this one plays out. It's like it's x plus 5, x minus 4. Five times negative 4 is your negative 20. 5 add negative 4 comes up positive 1. Making the x equal negative 5, x equal positive 4. If you proudly report both answers, I'm going to have to nick you. Hope it's obvious. Negative 5, illegal. You'd have a log for the check. Log base 5 of a negative 5. Plus log base 5 of negative 5 add 1, which is negative 4. Log base 5 of 20. You cannot put negative numbers into logs. It's out of their domain. The 4, though, I could put it up here and punch both sides, but all you really have to check for is that, yeah, log base that's positive. 4 plus 1 here is 5 is positive. Yes. X equals 4. Only legal answer. It will work when you plug it back in and punch. You cannot spot these illegal answers at the beginning like you can with fraction equations. Like if you had a fraction equation, 1 over x minus 1 plus 1 equals 3 or something, x equals 1 is illegal. If it ever came up, you'd be dividing by 0. Okay. So you can, on fraction equations, you can spot the illegal number right at the beginning, but not true on these log equations. No way to spot it. You got to work them out and then check the answers and see if they give you illegal numbers or an illegal answer. Let's see, I believe we did 51 last time. We did the first two. How about 52? Still off page 404. ln of an x minus a half plus ln2 equals twice ln of x. All right, on this one, you're going to want to collect the x's to both sides. X terms, I'm going to say to the left. As long as they're on the same side, that means I'm going to go ln of x minus a half minus twice ln of x. On the other side, negative ln of 2. Can't combine until you've stuck the 2 up, so that makes ln of x minus a half minus ln of x squared negative ln of 2. Now I can combine left side. The positive log stays on top. Negative log term on bottom, negative ln of 2. All right. Okay. We're still not ready for base C. You got to put this negative up. That'll make a negative 1 up here. That makes ln of x minus a half divided by x squared, ln of 2 to a negative 1. Now I'm ready to undo with base e. E to the ln of x minus a half squared, e to the ln 2 to the negative 1. That's an x minus a half. Sorry about minus, it's the wrong spot. X minus a half. So that's x minus a half squared is equal to 2 to the negative 1. So it's got a lot of steps in it. Going to go on to the next page here, a little long. You can send this down, making x minus a half over x squared, 1 over 2. Negative powers change level, sign. They change sign when you change levels with them. This can be done several ways. We can multiply, clear the fractions by multiplying both sides by 2x squared, or we can cross multiply. I guess I'll multiply. Common denominator here is 2x squared. We'll multiply through by it. So that gives me 2x squared, x minus a half over x squared, 2x squared times 1/2. X minus a half over x squared, 1/2, multiplying both sides by 2x squared. Cancel. X squared cancels here. I'll distribute the 2 through. That'll give me a 2x minus 1. Put that in parentheses. That's 2 times x. 2 times a half. 2's would cancel, leave me 1. Here, just the 2's cancel, equals x squared. I like to leave x squared positive. So I'm going to move my terms to the right on this one. So that'll put a 0 here, x squared minus 2x, and add 1. We're finally ready to factor. Hope everybody sees an x minus 1 and an x minus 1. Both factors give you x equals 1, so you'll have to write it once. You don't have to write it out twice. Is this illegal? I'm dying to know. The suspense is killing me. Check in the original. I'd have ln of 1 minus a half plus ln 2 twice ln of 1. This is positive. This is positive. This is legal. This is legal. X equals 1. All right, that was a long one. Is my answer. All right. About 5 minutes left. I don't think we did 53 last time. We'll work our way to 53. Page 404. Probably make this the last problem. Solve three plus log base 2 of x equals log base 2 of 5 plus log base 2 of x minus 2. We're going to combine both sides. With plus on everything, that means log base 2 of 3x. 3 and x would multiply. Log base 2 of 5 times x minus 2. Undo with base 2. 2 to the log base 2 of 3x. 2 to the log base 2 of 5 times x minus 2. These would all cancel. 3x equals 5 times x minus 2. I could have gone ahead and distributed. I was tempted, but just work it out a little slower. 3x, 5x minus 10. Subtract 5x. Negative 2x, negative 10. Divide by negative 2. X equals 5. We could check. You could really check in your head, but it's tough to teach what I'm seeing in my head. I'm really just 5 there stays positive, and if I have here 5 here, 5 minus 2 is 3, that's positive, it's legal. But just to write it out so everybody sees what I'm checking, 3 plus log base 2 of 5, log base 2 of 5, plus log base 2 of 5 minus 2. You can see it in your head that the log base 2 of 5's match, that's going to be the log base 2 of 3's match. But what I'm really checking for is that this is positive. When I plug back in, are my logs positive? And yes, they are. X equals 5. Legal. If it had not been, they'd cooked it so this had not worked, I would have called a no solution. Okay. There's some more problems, exponentials and logs from section 4.5. The test will be available today. Test covers chapter 4. Once again, there'll be a question form and a Google form. It'll work just like the quiz. You'll put your answers in on the Google form. Test is due Sunday night, but always extend the grace period. Would be 1 day, but Monday's Labor Day, so I extended it to Tuesday. But I won't accept any answers after next Tuesday, which would be September 8th. We'll go ahead and end the meeting and post this for your viewing pleasure.